Okay, guys, today, last lectures we have discussed how to get dataset, importing to library, importing the dataset itself, working with missing values, and the categorical, how to work with categorical data. And now today we will discuss about splitting the dataset into sample training and the test set. After that, we will discuss feature scaling. Okay, setting dataset into sample training and the sample test set. Actually, why we need it? Actually, we intentionally dividing our prepared full training dataset into one sample training dataset and the sample test dataset. Why? Because we would like to test our model itself. First, we are generating our model, and we are testing. How to test? Because if, for example, guys, in our further lecture regression classification, I will dig deeper about that. But today I would like to explain. Suppose in our Excel dataset we have here, for example, if we divide them, two of them will come to our test sample dataset. 8 of them will go sample train dataset. Okay, for these guys we already know how their outcome, how their preference. According to, I'm generating any kind of model here, and I'm building this model, and I'm testing for these guys. If it accordingly, I will get any kind of exact proper accuracy, how my data fits. How my data will fit. For this purpose, we are dividing our already built trained dataset into sample training dataset and sample test dataset. We will generate model and we will validate. We will check how it is good. Okay, yeah. In practice, it's accepted to divide them 80 to 20% percentage. 80% training, sample training dataset, 20% sample test dataset. Okay, let's go. How to do encoding? Splitting the dataset into sample train dataset and the sample test dataset. How to do it? For this, we need to import from scikit-learn model selection. We should from models file. It's the library name. It's the function name which we are going to import. We need train test split function. Okay, let's import a library from scikit-learn model selection, import train test split. Yes. Okay. Okay, now we have successfully imported, and now we are going to generate X train, X test, Y train, Y test. Why we need them? Because we have divided our datasets into this kind of sub data frames, sub objects. The test size will be 0.2 and my train size will be 0.8. Okay, we have our help. Here we need to write train test split. Okay. Do we have it? Yes. Train test split. Split arrays or matrices into random train and the test subsets. Yeah. Okay, what kind of parameter we have? Here we have x train, x test, y train, y test will be what? Train test split, train test split, and the parameters. Okay, let's see what kind of parameters. Arrays. What kind of arrays we would like to specify? It's clear. Our x variable and x and y. From x and y we would like to split, yes. And our next feature is test size. Test size. Test size will be equal to, as we have discussed, this 20% I would like to give my train dataset, 80% to my 80% to my sample train dataset, 20% to my sample test dataset. Yeah, it's, you can use 30-70, but 20-80 ratio is preferably accepted. Train size by default it will be 1 minus test size. Random state. Okay, it is really confusing concepts. Random state. Actually, you may understand, yeah, why I need random state. Suppose you here with 8 dataset, it is with 10 rows, it's very simple. But when you have thousands of hundreds of dataset, okay, they will be generating new rule, and they will be stated in a new order, because shuffling will go, because it will be transformed in a new way. That I should specify the random state. Okay, the random operation may happen, but I would like to say, okay, there should be strict, ordered, form or arrangement that it can run, it can compute the process. Okay, random state will be 0. Everything is fine. Let me see variable. My x test. X test should contain 2. X train should contain 8. Oh, everything great. 1, 2, 3, 4, 5, 6, 7, 8. Very good. Okay, guys. Now we have completed with our train test split. Okay. Now let's move on. Feature scaling. Okay. What's feature scaling? Feature scaling is the technique that standardizes the independent features. Okay, guys, what's feature scaling? Actually, feature scaling is the method, technique which standardizes the independent features for the fixed range. For example, actually, sometimes depending on the value of the one item, our weighting may change. For example, if we have very huge variable, very huge variable which has higher weight, or their scales are different, it will be very difficult to make proper unbiased computation. Suppose age and salary. Someone's age cannot be in thousands. It's impossible. Salary will be in thousands. when we do kind of clustering or something, we will find do what? We will find Euclidean distance of 2 points. If how I can say we have p1 x1 and p2 x2. How they are related? How is there any kind of numeric variable between them? With this kind of unscaled data, unnormalized data, it's very hard to do. That's why in statistics it's very famous to normalize them. Yeah, it's performed during the data preprocessing to handle high varying magnitudes or values or units. Yeah? If without feature scaling, our machine learning process will be very much biased. We will be focusing on one feature more than others. Actually, here it's not the problem with age, that the age is lower, but it's not a problem of salary, that salary is higher, because their scales are different. We are normalizing them. If one of them given 3000 and the second unit will give in a 5 kilometer, actually the 5 kilometers is bigger than 3000, but it has given 3000 and it has given only 5. It should be normalized. Both of them should be in one standard, and they should come on one condition, yes, one level. That's why it can be compared. Yeah, in order to solve, we have two kind of min-max normalization, minimum maximum normalization. This it will rescale the observation value distribution. Both of all the scaling will distribute values between 0 to 1. In min-max observation, we are dividing the current value from subtracting minus and dividing their maximum and the minima difference. Standardization, it will be done the difference from mean to from the exact variable to mean divided by our standard deviation. From statistics course, we know standard deviation any kind of shows their disparity, how the variance will be, how data is spread. It's related to that. Okay, guys, for these topics I recommend you to revise statistics course, because it was the prerequisite for this course. Yeah. Okay. I will ask detailed in exam, it may come, but you should revise statistics. Please revise statistics about scaling techniques. Okay, how to do scaling in Python? We should import the library first, standard scholar it's called, and we should feed them one by one. Okay, from sklearn. Okay, from sklearn preprocessing we are importing standard scholar. Okay, it has been done successfully. Now we should scale our features. We will scale our xtrain and the x set one by one. Our new xtrain will be equal to xtrain will be equal to standard scholar dot feed transform transform x train all rows and starting from column 1 till all of them. Yeah. Okay, let's check how it works. Okay, my X train has been scaled. Okay, let's do the same for X test. Test is equal to, I can copy paste from here. Only not X train, here X test. That's all. Yeah, okay, we have finished our pre-processing process. Now we have the pre-processing template. We can use it further. Of course, we should save it. My pre-processing template supported file. Okay. Guys, this pre-processing template we can use for our further projects. Okay, we have finished our entire pre-processing. Okay, last thing today in our class we would like to discuss data cleaning. Data cleaning is the process of detecting, correcting corrupt or inaccurate records from our dataset. Yeah, dataset, table, data frame, and anywhere. We should identify incomplete, incorrect, inaccurate, or irrelevant parts of the data, and by replacing, modifying, deleting, or the dirty data. Yeah. And types, there exist missing data, missing values. If data is not there, how we can work with them. If it is missing, we cannot do anything with them. It is really we cannot do any kind of calculations with them. If it is duplicate, it will give us biased outcome. It means some observations happened again, and our outcome will be biased. And irrelevant character term, if in some dollar sign or some extra signs, dots, will say that it will not be read as a proper numeric variable, and it will create problem. And null variables, if data not exist at all for this column, we can ignore them. Yeah? We can delete entire row, some cases. Yeah. About this data cleaning, we'll dig deeper in our coming class called data analysis. Yeah, in data analysis, separate chapters will be given, and we will dig deeper in that course. Okay, guys, thank you for your attention. Take care from coronavirus. Stay at home. Stay safe. I wish all the best for you. See you next time.